signal. While transmitting the wave, if suppose the wave is passing like parallel, what happens while moving the waves? It is colliding with the conducting walls and the wave is short-circuited. If the wave is short-circuited means whatever I sent, it is not passing up to the end, second end point. The wave is not transferring up to the deadline point. So what we have to do to solve this problem, I'm sending the waves, whatever I'm sending zigzag waves. If I send zigzag waves, what happens? It is colliding, even it can arise again and again, it will path. It can be continued using zigzag lines. So to send the propagation wave of zigzag line, we have to consider 2 points. The velocity of propagation is less than the velocity of the light. Velocity of the propagation, whatever the propagated wave we are transmitting, if we are using zigzag line, whatever the wave I am propagating wave, this wave must be less than the velocity of the light. This point we are seeing in this a reflection of, what is our topic? Reflection of a wave from the conducting plane. In this point, in this topic, what are the things we have to cover? A propagating wave is transmitting in straight line. It is short-circuited with the walls of the conducting plane and it is not going further. To solve this problem, I am using a wave of zigzag shape line. It is even it is colliding, it is rising again and passing up to the end. So if I want to transmit a zigzag wave, what are the conditions I have to follow? The first condition is good. The first condition is the velocity of the propagation is less than the velocity of the light. And the second condition is, the second condition here, the first velocity of light is less than the velocity. And the second one is here, not only normal, but reflection, we will, if the incident ray and reflection ray, we will call that there is a normal point also there in the reflection. This normal point is also considered here. The direction of the propagation is normal to the plane. Both are, whether electric field is or magnetic field, which one we are choosing is depends upon the waveguide that we are used. Here we will see in the PDF what is the point is given related to this one in this reflection of the line. What is the point is given? An electromagnetic plane wave in a space is a transfer TEM means transfer electromagnetic wave. If it is THM, transfer magnetic wave, whether it is in electric field or magnetic field. This here, the electric field and magnetic field, both are mutually perpendicular with each other. But what happening if I propagating the wave in straight line? It is colliding with the conducting walls of the waveguide. It is colliding with the conducting walls of the waveguide. To solve this problem, what I am using? I am sending the wave in the waveguide. In which fashion? Zigzag fashion. If I send the wave in zigzag fashion, it is bouncing to the walls and setting up again and traveling up to the end. Electric field that is maximum near the, so this here, the electric field is maximum near the center. Across the walls, the field is 0. To send a zigzag propagation wave, it has to satisfy 2 conditions. What is the first condition? The velocity of the propagation, Vp, is less than the free space. Second point is, the second one is that wave can no longer transfer electromagnetic wave. So based on the waveguide, either we are using electric transmission electromagnetic wave or magnetic wave. Wave requires not only a normal component. Here we are not only concentrating on a normal component, but also concentrating on the direction of the propagation. And we'll see the next page. Suppose this is the transmitted wave. To this transmitted wave, other part is reflected. In the slide page number 4, ma. Page number 4. Incident wave. This is incident wave and reflected wave, and other one is the normal to the plane. Another one is the normal to the. We have to draw this diagram, and both electric field and magnetic field both are perpendicular to each other. And one more point is, it is neither electric or so whether we are using electric field or magnetic field. At present, whichever is working is based on the type of propagation we are using. There will be two modes of propagation. The mode in which there is no electric field. If there is no electric field in the direction of propagation, in this direction it is traveling. If there is no electric field in the direction of propagation, we will call it as a transfer electric mode. Suppose if there is no component, only electric field is present, no component of magnetic field, it is called as transfer magnetic field. So when we will call transfer magnetic field and when we will call transfer electric field? Not suitable. Transfer directly, I will write this part. The next slide I will show you. These 2 points are important here. Two modes of propagation. If there is no component of electric field component is not there, then it is called as what? Transfer electric field. If there is a no component of magnetic field component is not there, then it is called as transfer magnetic field mode. So this is another diagram. We are taking zigzag lines, and this is not only normal to the plane. Normal means straight. Not only normal to the plane, there is also direction of propagation. To this direction of propagation, I am taking VC, actual velocity is VC, and the velocity across the normal to the plane is Vn, and the velocity across the parallel direction is Vg. 3 parameters I am taking. What is VC? Actual velocity or velocity of light. VC is called velocity of light. What is Vn? Normal to the plane, above diagram. See the above diagram? Normal to the plane, Vn. Vn is normal to the plane, and another velocity is Vg. Vg is velocity across the direction of propagation. Direction parallel is Vg. From this, I am writing one equation. What is the equation? Vg equal to Vc times of sine theta. Vg equal to Vc times of sine theta. And normal to the plane, Vn equal to Vi times of cos theta. These two are over. Next, I am writing in terms of wavelength. Wavelength across propagation. Delta P equal to delta naught by sine theta. Wavelength across the normal to the plane is represented with delta n. Delta n equal delta naught by cos theta. These we will use in the next derivations. Next main important essay question. I will substitute these equations. What is in place of delta P? There I will substitute delta naught by sine theta. In place of delta N, I will substitute delta naught by cos theta. Now we will see the phase velocity. What is phase velocity? Electromagnetic wave has two velocities. It propagates in or change the phase. Here, what are the two velocity? Group velocity, Vg term we have, and velocity of the light is Vc. Here, in free space, what we will call velocity of light call. Another, we will call the term as Vg. This is velocity of the light. velocity of the light when it is propagating. Here, velocity of the light Vc equal to f times of lambda naught, and the formula is 3 into 10 to the power of 10 centimeter per second inverse, where f is the frequency of the electromagnetic wave and lambda is the wavelength. And now I'm propagation, wavelength of propagation. Wavelength across the propagation wavelength, lambda p equal to lambda naught by sine theta. And 1/4 formula we have Vp, velocity across the propagation Vp equal to frequency times of delta p. And the previous equation, what is delta p? Delta p is equal to delta naught by sine theta. So f times of delta naught by sine theta. Velocity equal to frequency or times of wavelength I am taking as a Vc. So it is Vc by sine theta. So what we calculated? We calculated propagation velocity Vp equal to free velocity in a free space by sine theta. Just this is short questions. We will use these equations in the essay question substitution part. Next, parallel plane waveguide. Next topic. Parallel plane waveguide. What is this parallel plane waveguide? We are transmission lines. I'm transmitting. One side I want to keep open. Other side I want to short circuit or I want to close other side. This one side is open, another side is closed. This closed part once I kept here. Next to this closed part, I moved to this side. Third term, I moved this closed. Always this is open part. One side is always open part. I'm talking about the closed section. Transmission of line. This is transmission of line. In this transmission of line, why it is normal load? Old board రావట్లేదంటన్నా. Try once again. Cursor. Here, transmission of media. I'm sending my input signal from this side. This side, I want to close other end. Suppose if I close here, second option is the same media of line. Instead of this point, I'm closing here. In third case, I'm closing here. In another case, I'm closing here. In another case, I'm closing here. So input part is always opens. Output part is short circuited. Where I'm keeping this short circuited line. Once I kept here. Second time I kept short circuited line here. Third time I kept short circuited line here. Fourth time I kept short circuited here. Fifth time I kept short circuited here. Suppose if I kept short circuited here, the wavelength here I am taking as lambda. Actually, it has to be here. But where I kept here. At that time, it is lambda by 2. Suppose I am keeping my short circuited here. Suppose I am keeping my short circuited here. Then what is the wavelength? It is 2 lambda by 2. Suppose this second closed point I am keeping here. Then what is here? 3 lambda by 2. Suppose I am keeping here, it is 4 lambda by 2, which we will see this one in the textbook part, we will see the same one. Whatever we are discussing, still in the short answer questions only. Here you have many derivations, very important derivations as a essay questions. Still we are in short. After completing short part, I will cover essay part. See here, See these two diagrams. After discussing diagrams, we will go for the matter. What is here? First end is open. This end is open. Other end is short circuited. Suppose it is short circuited here. If this is short circuited here, only from one side we are passing. At that time, what is the status of voltage? What is the status of current? Current will be maximum, voltage will be minimum. See here, what is the topic, how it is transmitted in transmission lines? The lines are transmitting. Other side is short circuited. If other side is short circuited, what happens? Whatever the ray we are incidenting, it is reflecting back again. It is reflecting back in which mode it is reflecting? It is reflecting in standing waves. Here, what is the meaning of standing waves? These curved shapes, Nayama, these are standing waves. Actually, other side is closed. Again, it is returning back. This is called as standing wave. As other side is closed, again it is coming back. Again it is coming back. So, when it is coming back, what is the status of voltage? Voltage is 0 and current is maximum. Maximum current is flowing, voltage is 0. Why it is happening like this? Because rectangular wave has two pairs of walls. Other pair is closed. So what is the next diagram? In the other pair is closed. Suppose this is the short circuited one. Suppose this is the short circuited one. The next standing wave, how much it is? Lambda by 2. Suppose short circuited place I kept here. What is the wavelength at the time? 2 lambda by 2. Suppose the short circuited word in the third position. What is the wavelength? 3 lambda by 2. So, in this final conclusion of this diagram, what we are discussing is a transmission of wave. One side is closed. From other side, I am sending wave. As it is hitting to the wall and reflecting back. When it is reflecting back, it is moving in terms of standing waves. In moving it in terms of standing waves, what is the status of voltage? 0. What is the status of current? Current is maximum current is flowing. Suppose this line, if I move forward, this line, actually this is at this point, but the short circuited line, I am shifting. If I shift here, then we will treat wavelength lambda by 2. Suppose it is shifting here. We will treat this wavelength as 2 lambda by 2. Suppose I am shifting at this place. The wavelength I am treating as 3 lambda by 2. And velocity is 0. Current is maximum. What are the wavelengths we are choosing? 0 voltage at a distance of lambda by 2, 2 lambda by 2, and 3 lambda by 2, etc. Suppose second wall is placed at a distance of 3 lambda by 2. Here we are keeping second wave. Second wave wall is placing across 3 lambda by 2. Then this diagram, overlapping of the incident ray as well as reflecting ray. This is the diagram. How we are getting this diagram? Transmitter line is open. Closed line is across with small distance. So there is overlapping of incident wave as well as reflected wave. So it looks like a zigzag wave. How it is looking like a zigzag wave. So this is the diagram which, so what we discussed till now? What are the points we discussed in this chapter? We saw just the introduction part. Stuck అయిందమ్మా చూస్తారు.
Ma'am, are you sharing any screen or what?
Yes, I'm sharing, ma. It's not getting.
Screen share కావడం No, ma'am. We are on stuck whiteboard.
Okay, I will send. Now are you getting?
Yes, ma'am.
We will recall once again in this what we discussed. First one is introduction. In introduction, what we discussed, I am sending a wave from transmitter to receiver with radio frequency energy, but some energy is losing from transmission side to receiving side. That is called as transmission line. While sending, I am using different types of waveguides. Here waveguides. Waveguide means the equipment part. Device is called as waveguide. Whatever the wave I am transmitting in the direction, this is called as guided wave. Here we have different types. Okay, बताएं. Next क्या discuss करें इसमें? What are the advantages of over waveguides over the normal coaxial cables? Is the very important point is power handling capability is good, and it is 10 times, power is 10 times faster than normal coaxial cables. And next what we discussed, reflection of wave from conducting plane. In reflection of wave from conducting plane, what we discussed, if I send a normal wave, what happens? It collides with the walls of the device. To solve that one, what we are using? We are using zigzag propagation wave. To consider zigzag propagation of wave, velocity of the propagation is less than the velocity of the pre-place. And also we are concentrating on the direction of propagation, on which direction it is flowing. Based on that one, here I am calling as a two modes of propagation. One is transmitting electric field in the direction of propagation. Another one is transmission of the magnetic field in the direction of propagation. And we saw some simple formulas. Next, calculated phase velocity. Next, what is the next topic? Parallel plane waveguide. In parallel plane waveguide, what you will write? You will discuss about the other end. Other end is short circuited. If other end is short circuited, what happening? It is reflecting back. In which direction it is reflecting back? It is reflecting back in terms of standing wave. It is reflecting back in terms of standing wave. Velocity is less, current is maximum. But this other end, if I move, what happens? I moved across the distance lambda by 2. Again, this line, this other end, I moved to 2 lambda by 2, 3 lambda by 2. These parts we discussed, introduction part. So small 3 topics is covered. And what are the advantages of waveguide? It is 2013 question, ma. What you will write? Advantages of waveguide means which paragraph you have to write in this? Advantages of waveguide means this one you have to cover, this paragraph. Where this is? This paragraph you have to cover for the advantages of waveguides means idhar se idhar tak likhna, which is a question in 2023. Another short question is what is the possibility of another short question from unit 1? Another short question is discuss about reflection in parallel waveguides. What we discussed, reflection in parallel waveguides, both the kya likhna ma? Other side is short circuited. If other side is short circuited, how it is? Bol ke likhna. What is phase velocity? What is phase velocity means Vp. What is the formula of Vp? We discussed phase velocity.
Vp is equal to Vc by sin theta.
Vp equal to Vc by sin theta. That one you have to write here. This part you have to write. What is phase velocity? बोलते तो इधर से इधर तक लिखना है पूरा. This is another short question. Now we will come to the next topic. From unit 2, here what are the major topics which we have to cover in this is?
Ma'am, excuse me, ma'am.
Chepama.
Parallel plane waveguide, another question is there, ma'am. Lambda by 2, 2 lambda by 2, 3 lambda by 2.
ఎక్కడమ్మా the parallel plane waveguide లో
ఎక్కడ వరకు రాయాలి మేడం అది?
ఇక్కడ వరకు రాయాలమ్మా. ఇది ఎక్కడ వస్తుంది? ఈ డయాగ్రామ్ ఎప్పుడు వస్తుంది చెప్పండి? ఫిగర్ 1.6. ఇప్పుడు మనం 3 లాంబ్డా బై 2 మన ఇన్పుట్ రెండు సేమ్ ఉన్నప్పుడు ఈ డయాగ్రామ్ వస్తుంది. ఫిగర్ నెంబర్ 1.6 ఉందా డయాగ్రామ్?
అక్కడ దాకా రాయాలా మేడం?
ఫిగర్ నెంబర్ 1.6 డయాగ్రామ్ ఎప్పుడు పాసిబుల్ అవుతుంది? 3 లాంబ్డా బై 2 అంటే మన షార్ట్ సర్క్యూటెడ్ ని అదర్ ఎండ్ ని మన ఇన్పుట్ ఎండ్ దగ్గరికి తీసుకొచ్చేస్తున్నాం. ఎక్కువ గ్యాప్ లేదు ఇన్పుట్ కి అవుట్పుట్ కి. అప్పుడు మనకు ఫిగర్ నంబర్ 1.6 వస్తుందని చెప్తాం మనం.
ఇది కూడా షార్ట్ క్వశ్చనే కదా మేడం?
ఇవన్నీ షార్ట్ ఏనమ్మా. వాట్ ఈస్ ఫేజ్ వెలాసిటీ ఒకటి, వాట్ ఆర్ ద అడ్వాంటేజెస్, వాట్ ఇస్ ద రిఫ్లెక్షన్ ఇన్ ప్యారలల్ ప్లేన్ వేవ్, ఈ 3 షార్ట్ క్వశ్చన్ కిందనే వస్తాయి. మెయిన్ ఎస్ఏ క్వశ్చన్స్ ఉన్నాయి, ఇప్పుడు చూద్దాం. ఎక్కడ స్టార్ట్ అవుతుంది? ఇది వన్ ఆఫ్ ద వెరీ వెరీ ఇంపార్టెంట్ ఎస్ఏ క్వశ్చన్. ఇది కంపల్సరీ గెస్ చేయొచ్చు. Group and phase velocity in waveguides. చాలా ఇయర్స్ క్వశ్చన్స్ లో ఇది రిపీట్ అయింది. మెయిన్ ఇంపార్టెంట్ క్వశ్చన్ అంటే ఇది ఒకటే. డిఫైన్ ఫేజ్ వెలాసిటీ అండ్ గ్రూప్ వెలాసిటీ. ఈ యూనిట్ 2 లో ఇది ఒక్కటి ఇనఫ్ షార్ట్ కి. డిఫైన్ ఫేజ్ వెలాసిటీ అండ్ గ్రూప్ వెలాసిటీ. Now we will see this question. Define phase derivation part అనమాట.
మ్యామ్ వన్ డౌట్ మ్యామ్, వాట్ ఆర్ ద అడ్వాంటేజెస్ ఆఫ్ వేవ్ గైడ్స్ అన్నప్పుడు ఇంట్రొడక్షన్ రాసి వేవ్ గైడ్
ఇంట్రొడక్షన్ కంపల్సరీ కొద్దిగా రాయాలి. ఇంట్రొడక్షన్ రాసి దీని పవర్ ఎబిలిటీ మంచిగా ఉన్నది, ఇట్ ఈస్ 10 times faster than the coaxial cables అని రాయాలి.
ఎందుకు మనకి అడ్వాంటేజెస్ కొంచెమే ఉంది కాబట్టి ఇంట్రొడక్షన్
కొంచెం ఇంట్రొడక్షన్ ఇంక్లూడ్ చేయాల్సి వస్తుంది.
ఓకే మ్యామ్.
మనకి ఇప్పుడు యూనిట్ 2 లో ఒకటే క్వశ్చన్ ఉంది, అదే ఇది.
ఓకే.
పేజ్ నెంబర్ ఎక్కడ ఉంది? ఇది కట్ ఆఫ్ వేవ్ లెంగ్త్, గ్రూప్ వెలాసిటీ అండ్ ఫేజ్ వెలాసిటీ. ఇక్కడ చూడండి, గ్రూప్ వెలాసిటీ అండ్ ఫేజ్ వెలాసిటీ ఇక్కడ కూడా ఉంది. ఇక్కడ చూడండి, parallel plane waveguides. I will share this notes, same whatever I explained, that one is here. Completed now? Parallel waveguide. What is the next topic, ma'am? Group velocity and phase velocity. What are the things we have in group velocity? Group velocity is represented with Vg and phase velocity is represented with Vp. Using previous discussed formulas, here I am writing two equations. What are the two equations I am writing? First equation is Vg. What is Vg? Group velocity. What is the formula of Vg? Vg equal to Vc sin theta. And next another, what is the formula of phase velocity? Vp. Vp equal to Vc by sin theta. And what is the difference between these two equations? Cheppandi. What is the difference between these two? In this group velocity, sin theta is in the numerator. In phase velocity, sin theta is in the denominator. Now I am taking the product of 2 in the parallel plane waveguide. In parallel plane waveguide, these two are multiplied. If these two are multiplied, means it is the product of Vg into Vp. And Vg into Vp, what happens? Sin theta will be cancelled. And what we will get? Vc square. So Vg into Vp equal to Vc square. Next, in the previous, we used one equation, Vp equal to F lambda. What is the next equation we have? Vp, phase velocity, Vp equal to frequency times of lambda p. And here, F I am writing, and I am substituting value of p. What is lambda p? Lambda p equal to lambda naught by 1 minus lambda naught by lambda c whole square. You will get doubts from where we got this one. In this textbook, we have this one. I will show. From there I written, but no need of not that much concentrating on the topic. Here we have few formulas in the previous derivation. What is lambda p formula? Equation number 2.6. Using previous differences formulas, I am substituting. Here lambda p formula equal to lambda naught by under root of 1 minus lambda by lambda c whole square. That one I am substituting in group velocity and phase velocity substitution. Just see here. What is lambda p previous? What is lambda p? Lambda naught by under root of
1 minus lambda 0
by
by
lambda c whole square. That one I am substituting across lambda p. V equal to n lambda, f lambda. N means f equal to, I am taking this as a velocity of light, Vc. I am substituting f lambda equal to Vc. So what is the formula we are getting? Vp equal to Vc by under root of lambda minus lambda c whole square. This is equation number 2.9. And I am using this substituting equation 1.14 into 1.13. Where we have this 1.14 and 1.13, just turn back and check. What is equation 1.14? What is the equation 1.13? Usme substitute karna. Previous 1.4, 1.3 in unit 1. Just now we discussed those two formulas.
There is no 1.14.
No 1.14, only 1.4, 1.3.
Yes, ma'am.
Or else Vg equal to Vc, or else you can do directly remember this formula. What is
No, ma'am.
Vg?
We put it from 2.8 equation.
2.8. These two is wrong. This step is wrong. We are keeping from 2.8. See here, what is equation 2.8? Vg into Vp equal to Vc square. From there, I am writing Vg. What is Vg? Vc square by Vp. Vc square is kept as it is. In place of Vp, I am substituting reciprocal. As it is in the denominator, it is reciprocal, and we got the formula of Vg. This is very, very, very important short question from block 1. As we can expect every year this question expecting, and is there also in the previous question papers. Again, we will recall what would be very, very easy. What is Vg? What is Vp?
Group velocity and
Vg is group
Phase
velocity.
velocity.
Vc is velocity
Phase
of light. Vp is propagation across the propagation of peak velocity, phase velocity we will call. From Vg equal to Vc by sin theta, Vp equal to Vc by sin theta. Vc sin theta, this is Vc by sin theta. From this multiplication, I am taking Vg into Vp. We got Vc square. And next what I did, I am writing in terms of wavelengths. After that, substituting in this, we got direct equation Vg equal to Vc under root of 1 minus lambda by lambda c whole square. From the result, what we are observing? As Vg decreases, this lambda naught is in the numerator or denominator? Lambda naught is numerator. As Vg decreases, lambda naught is also decreasing. Propagation is signal in a way lower than free space. It is also seen that Vg decreases as lambda naught is approaches to lambda c. As lambda g naught is approaches to lambda c, we will call as Vg is decreasing. Is this okay, my topic?
yes,
Okay,
ma'am.
This is, you can expect important short question. Next, we will come to the derivations part, bigger essay questions. What are the topics here we have to cover from unit 3? Today we will see rectangular waveguides. In the tomorrow class, I will cover circular waveguides. As it is lengthy topics, today we will see rectangular waveguides. What are the subtopics we have in rectangular waveguide? Transfer magnetic waves, cutoff wavelength of magnetic mode, next field pattern, next TE mode, next TE mode, field pattern. How we will get questions first we will see, and then we will come to the topic. Regarding to this.
Ma'am, in the previous model questions, unit 2, define phase velocity and group velocity and derive expression for Vp and Vg. Both are same questions.
Same.
Yes. Question 2 and question 5.
Question 2 and say question 5 రెండు ఒకటే దానికి మీకు వస్తుంది. డెఫినేషన్ రాసేసి డెరివేషన్ చేయాలి.
Same. This one group and phase velocities in waveguides, that much only.
మీకు డెఫినేషన్స్ ఎక్కడ ఉన్నాయి చూడండి. ఇందులో ఇంతకుముందు చూపించాను కదా, డెఫినేషన్స్ సపరేట్ గా మెన్షన్ చేశారు. డెఫినేషన్స్ యూనిట్ 1 లో ఇచ్చారు చూడండి డెఫినేషన్స్.
ఎక్స్ప్రెషన్ అన్నప్పుడు ఈ డెరివేషన్ రాయాలనా మేడం?
డెఫినేషన్ కి
డిఫైన్ అన్నప్పుడు డెఫినేషన్స్ రాయాలి.
కానీ ఓన్లీ డెఫినేషన్స్ కి మార్క్స్ పడాయమ్మా, కంపల్సరీ డెరివేషన్ పార్ట్ చేయాలి అక్కడ.
అదే మేడం, అందుకే క్లారిటీ.
ఫేజ్ వెలాసిటీ అంటే ఇక్కడ ఉంది చూడండి, Vg ఈక్వల్ టు Vc sin θ, Vp ఈక్వల్ టు F లాంబ్డా. ఇది మీకు ఇక్కడ డెఫినేషన్ కవర్ అవుతుంది, కింద డెరివేషన్ వస్తుంది. ఏది ఇచ్చినా మీరు డెరివేషన్ అయితే చేయాలి అక్కడ.
ఓకే అమ్మా.
Next is, first I will show you which type of questions you will get, and we will go for the derivation part. At the last page, what are the questions is there regarding to third block, unit 3?
Characteristic of rectangular waveguide, circular waveguide. Derive the field equation in rectangular waveguide.
Waveguide.
Propagation of TM waves
Yes,
in
in
rectangular
rectangular
waveguide.
waveguide. Expression for
TM
TM equation.
field equation in rectangular waveguide.
So each topic can be chosen as one essay question. Each topic is chosen as one essay question in the whatever the subheadings we have here. What are the inside topics? Each one can be treated as one essay question here. In unit 3. One question is characteristics of
Rectangular waveguide.
waveguide. First rectangular waveguides introduction part we have to do. Next TM mode. So next field effect of TM mode. Next one type of essay question is TE mode. Next is field pattern of TE mode. So 4 types of essay questions we can guess from this rectangular waveguides. If the rectangular waveguide is understood, you will understand easily circular waveguide. Now we will say rectangular waveguides. What is the rectangular waveguide introduction? If the cross section of the tube is in terms of rectangle, if the cross section of the tube is rectangle, we will call it as a rectangular waveguide. If the cross sectional area shape of the tube is in circular, it is called as circular waveguide. And here we are conducting, here we are considering which topic we are considering here? Which topic we are doing? Rectangular, circular?
Rectangular.
Rectangular. So the cross sectional area is in rectangular, in circular?
Rectangular.
The cross section area is in rectangular. So we are taking this as a rectangular waveguide. Again, in the rectangular we have two pairs of conducting walls. Waveguide where A represents dimensions, B represents height. We are taking in terms of A and B. A is width, another one is in height. This A, this is B. And we are taking diagonal axis as Z-axis. This is X-axis, Y-axis, and Z-axis. Just in the previous topic, I said with 2 modes of propagation, TE mode,
TM mode.
TM mode. In TE mode, there is no electric field component. Did you remember the sentence?
Yes, ma'am.
In TE mode, there is no electric field component. In TEM mode, there is no magnetic field component. That 2 lines. And one more thing is electric field and magnetic field both are perpendicular with each other. And these 2 sentences are given in this paragraph. Now we will see what is this. All electromagnetic fields in the space between the conductor obeys some laws. Always electric field is perpendicular to which field? Magnetic field. On the surface of the conductor, electric field is parallel and surface must be 0. I said in the center, electric field is maximum. Across the conducting walls, electric field is minimum. Why this is happening? This is happening because I am sending zigzag line. The transmission is in terms of zigzag. Electric field must always be perpendicular to the surface of the conductor. The magnetic field is always perpendicular to the electric field. So we have 2 basic equations. First, I will explain another one and then we will come to this textbook part. See here. What is rectangular waveguide, ma? When the cross section of the metal tube is in rectangular shape, it is called as rectangular waveguide. Again, it has how many pairs of conducting walls? It has 2 pairs of conducting walls. It represents with A and B. A is the width, B is the height, and A is the width. Next, to solve this derivation, I am using Maxwell's curl equation. You know the equation number 1 you studied ma Maxwell equations వచ్చాయా మీకు?
Yes, ma'am.
ఏం
In the
థియరీలో
first year,
ఫస్ట్ ఇయర్ లో చదివారా? ఎన్ని ఉంటాయి Maxwell equations? 4. Here we are using Maxwell's curl equation in terms of magnetic field 1. What is delta cross H? Delta cross H equal to dou D by dou T plus J. To this one, I am keeping in homogeneous medium J equal to 0. If J equal to 0, if I substitute J equal to 0, what happens to del cross H ma? Del cross H equal to dou D by
Dou D by dou T.
dou T. Same way, I am substituting dou by dou T equal to J omega. What is the value of dou by dou T? Dou by dou T
J
equal to
omega.
J omega. And now you substitute in this equation and take D as epsilon electric field E and substitute in equation number del cross H. And now what you will get del cross H in place of dou by dou T? What I am substituting?
J rho.
In
J
place
rho.
of dou by dou T, I am substituting J omega. In place
J
of D, I am substituting epsilon E.
epsilon E.
So what you will get final equation?
J omega epsilon E.
You will get del cross H equal to
J omega epsilon.
epsilon E. Same way, for the electric field, I am writing equation. And now you observe equation 3. How we got equation 3, ma?
Instead of dou by dou T equals to J omega and B equals to mu H.
Mu H. What is E? What is B? E means
B.
electric field.
E
H means
means magnetic field.
E means electric field. H means here magnetic field we are using.
Magnetic field.
Magnetic field. We got which one? We got del square, del cross E we got, and what we got? Del cross H. And what are the equation numbers? These two equations. Equation number 2 is transfer magnetic or transfer electric field equation. Equation number 2 is transfer magnetic field or transfer electric field equation.
Transfer electric field, na? There is no electric component.
What is equation 4 and 5? What is equation 2 and 3?
Wave equations.
Hmm?
Wave equation.
Wave equation.
Yes.
Is it both are same?
One is electric field, another one is magnetic.
One is
Both
magnetic
are
field.
different, not same.
Different. Transfer electric field equation, transfer magnetic field equation. Again, I am revising what we discussed. What is del cross H? Dou D by dou T plus J. J equals 0 in terms of dou by dou T, I kept J omega. In place of D, I kept 1 times epsilon E get. For magnetic field, I kept mu H and I brought two equations, del cross H and del cross E. Is it okay up to here?
Yes, ma'am.
Next, I am writing wave equations. Two equations you have to learn. Those two equations is for one for electric field, another for magnetic field. For electric field, what is the equation? Del square H equal to minus omega square mu epsilon H bar. What is del square E? Minus mu omega square mu epsilon E. Next, we will take equation 5. From equation 5,
Ma'am, in the textbook it is different, ma'am.
Textbook is different. I will share this, ma. Because in the textbook, direct equations is written.
Okay, ma'am.
It is difficult to by heart direct equations.
Yes, ma'am.
Here, I wrote step by step how we got that one. See, from equation 5, I am taking across z-axis. If I take across z-axis, what is the equation will change? Del square Ez equal to minus omega square mu epsilon Ez. Now we will expand delta. What is delta? Dou square by dou means delta square I'm writing in terms of x, y, z components. Delta square I'm writing as dou by dou x square, dou square by dou y square, dou square by dou z square. And we are writing for whom? I'm writing for here Ez. For which one I'm writing, ma? Along z axis I am writing. For that I am taking dou square Ez by dou x square, dou square Ez by dou y square, dou square Ez by dou z square equal to, I wrote RHS as it is. Is it as it is RHS? Yes or no?
Yes, ma'am.
మ్యామ్ ఫోర్త్ ఈక్వేషన్ టీఎం వేవ్ కాదా మ్యామ్?
Fourth equation.
టీఎం వేవ్ కదా మ్యామ్ అది?
Fourth equation TM wave. Fifth
Fifth
equation
TE wave.
TE wave. ఇది రివర్స్ వచ్చింది.
ఉమ్,
ఇది వచ్చింది కదా.
అవునవును
TM. ఇది
అవును
TE wave.
టీఈ వేవ్.
TE wave. Now we are writing for E here. Next time రాసామేమో. Now in place of dou by dou z, I substituted minus gamma. Dou by dou z plus what I am keeping? I am keeping minus gamma. And now you cross check the equation again. Dou square is, in this I am substituting and rewriting again. Dou square is z by dou x square. Dou square is z by dou y square. In place of dou square by dou z square, what I am writing?
Gamma square.
Minus gamma square times of Ez equal to minus omega square mu epsilon along z axis Ez. First two terms written as it is. Next, Ez is common. What we will get, ma?
Ez common gamma square plus
Gamma
omega
square
square.
plus omega square mu epsilon equal to 0. On a minus gamma whole square just same వస్తుందమ్మా.
Plus, ma'am.
ఎస్ఏ వస్తుంది. సో EZ కామన్ తీస్తే gamma square, this minus is in the RHS side, it becomes plus. So plus gamma square mu epsilon equal to 0. So gamma square omega square mu epsilon equal to, I am treating this as one constant. What is the constant?
Kc square.
Constant is Kc square. And rewriting equation once again. In this, I am substituting. And now what is the equation? Dou square Ez by dou x square, dou square Ez by dou y square.
Plus Kc square Ez equals to 0.
Plus Kc square Ez equal to 0. Same way, I am writing equation for magnetic field. Once we got for electric field, same way I wrote for the magnetic field. And now what is the equation for the magnetic field? Same way. Dou square Hz by dou x square, dou square Hz by dou y square, plus Kc of Hz equal to 0. Now we have to solve equation 6 and 7 to calculate the components Ex, Ey, Ez, Hx, Hy, Hz. Just you are open your textbook. What is the difference between those derivations and these derivations? I will show you here in the textbook. Direct equations is written. What are the equations number? Equation number here. Dou Hz by dou y undama. J omega epsilon Ex, Ey, Ez ichara. Now we will derive those. Now using 6 and 7, I am calculating Ex, Ey, Ez, Hs, Xy, Hz. Where we got after calculating, I will show you. 8, 9, 10 ఉన్నాయమ్మా చూడండి. ఈ 8, 9, 10 ఈక్వేషన్స్ ని మీకు టెక్స్ట్ బుక్ లో డైరెక్ట్ ఇచ్చేసారు. ఒకసారి ఓపెన్ చేయండి పేజ్ నెంబర్ 15 టెక్స్ట్ బుక్ లో.
16, ma'am, in textbook.
15 16 చూడండి ఉన్నాయా?
16.
3.4 లో
3.4 లో 3.5 లో 3.4 equations is related to the electric field. 3.5 equations is related to
3.5 is the electric field.
electric field. 3.5 కి HX, HY, HZ ఉంది కదా.
Okay, okay, ma'am. Other
Magnetic
side is
field equations. 3.4 లో EX, EY, EZ ఉందా? EX, EY, EZ.
3.4.
3.4 EX, EY, EZ.
Yes, ma'am.
Those are magnetic field equations. So, in the textbook, it is given directly. In notes, step-by-step simplification is there to get these equations. Now we will see those step-by-step how we got. From up to equation 6, 7, is it okay, ma?
Yes, ma'am.
Now we will see from equation 2. What is equation 2 above? What is equation 2?
Del cross H equals to J
Del
omega
cross H equal to?
J omega epsilon E.
Epsilon E. From this, we got the next one. See here, from equation 2, niche aake dekho, from equation 2, using above parameter substituting in equation 2. What is equation 2? Del cross H equal to J omega
J omega epsilon E.
E. Del cross H equal to J omega epsilon E. And I'm taking E as what? What is E? E equal to
E naught into E power
E
of
naught
J
times
omega
of
t.
J e to the power of J omega t. And also I'm considering delta. What is delta means? I dou by dou x, J dou by
J
dou y,
double
K dou by dou z.
dou by dou
What is capital E?
EX
EX
I bar
EX
EY
of I, EY of J, EZ of K. What is H? HX of I, HY of J, HZ of K. Using these all above parameters, and I am substituting in equation 2. After substituting in equation 2, I am taking this method cross product vector format. Is it I, J, K? What is del? Dou by dou x, dou by dou y, dou by dou z. What is H components? HX, HY, HZ. This is del cross H I am writing. Here, del cross H undama? Deenki rastunnanu. Del cross H. I am writing for del cross H. IJK, dou by dou x, dou by dou y, dou by dou z. Now, I times of cross multiply. What you will get? Dou hz by dou y minus dou hy by dou z. Is first term clear?
Yes, ma'am.
Minus j times what you will get?
Dou by dou
X of
HZ by dou
HZ,
X.
dou by dou z of hx. Next, what is third term? Dou by dou x of hy minus dou by
Dou
dou
by
y of
dou HX of
h.
dou Y.
And what is the RHS term we have?
J omega
Epsilon.
E bar.
E bar.
Epsilon
J
E.
omega E bar. J
J
omega epsilon in place
bar.
of E bar. What I am writing?
EX
EXI,
bar
EYJ,
EY
EZK.
EZK.
I substitute LHS side as well as RHS, and I'm substituting in place of dou by z, dou z. In place of dou by dou z, em pettalama?
Minus
Minus
gamma.
gamma.
Now we substitute in the above equation minus gamma and rewrite the equation again. Now you cross check.
Yes, ma'am.
I times of dou h by dou y. Vachinda?
Yes, ma'am.
Dou by dou z ఏం చెప్పాను?
Minus X. Minus gamma.
This is
Minus
minus
gamma.
gamma, not
Gamma,
x.
gamma.
Minus of minus plus hy. Okay, na first term?
Okay, ma'am.
Next come to second term. Minus j times dou. It is x term, so write as it is. Next, in place of dou by dou z ఏమొస్తుందమ్మా?
Minus gamma, minus
Minus of minus plus వచ్చేసింది. Next third term లో x ఉందా? Gamma ఉందా? Third term లో z component ఉందా? లేదు కదా?
Dou by dou Z not there, ma'am.
Yes, so wrote third term as it is.
Same
Whatever
as
is
it
up, again the same thing is copied. Next written RHS part. Now I am comparing the coefficients of IJK coefficients. Comparing IJK coefficients. What is ith coefficient here?
Dou x z by
Z by
dou
dou
y
y plus gamma
gamma
HY.
is equal
Gamma
to
HY is equal to what you have across RHS side?
dou
J
omega
omega epsilon of E of
x
X. Okay, now? Next second term,
h
dou Hz by dou X plus gamma times of Hx. Why it is 2 minus? Minus is multiplied inside.
s ma'am.
Minus gamma Hx is equals to J omega epsilon of Ey. Dou Hy by dou X minus dou Hx by dou Y equal to J omega epsilon by Ez. These three given directly in the textbook.
Yes, ma'am.
Now, I will keep the overview. You cross-check once again. After clearing this topic, I will continue the next topic. Just go through from the beginning. Is it okay? Means I will continue the next one. What we are discussing, just I will keep 2 pages. You cross-check what we discussed. Just go through the first page. If it is okay, I will show the next second page. Just to review what we discussed, because this is very lengthy derivations. After understanding one by one part, we will go for the next one. Just go through the first slide. If okay, I will show the next one. Is first, can I scroll down? First wrote 2 equations, del cross H and del cross C. And wrote 2 wave equations. TE wave, another one is TM wave.
TM wave.
Next, what we did? Expanded. From equation 5. Just go through one by one step. If it is clear, I will continue the next derivation part.
Okay, ma'am, clear. Send the notes, everything is clear.
Okay. At least if you understand this, I can go further.
Yes, ma'am, understand.
Next, up to where we discussed, ma'am, we got 3 equations, 8th one, 9th one, and 10th one. And now,
IJK coefficients equation.
coefficients. Same way now we will do for electric field, and we will bring 3 more equations. Now, same procedure for electric field. What is del cross E? This is my eraser pencil.
Del means dou by dou x. As like that, we have to write, ma'am. H means H I X H Y Z H Z K.
Go through this page and how we got 11th equation, 12th equation, and 13th equation. These 3 equations is same procedure what we did in the previous. Just go through this page. Checking for pencil. Okay, let's see. Now, what is del cross C? Del cross C equal to minus j omega mu times of magnetic field. After this, I, j, k. Next, dou by dou x, dou by dou y, dou by dou z. Next, ex, ey, ez. Next, cross multiplication. I times of dou ez by dou y minus dou ey by dou z. Same way written 3, and in place of dou by dou z, what I substituted? In terms of dou by dou z, I substituted
minus gamma.
minus gamma. And equating LHS and RHS, what we got? We got
And
three
three
equations.
equations.
What are the three equations? In terms of electric field equations. Previous equations, what we got is in terms of magnetic field equations.
Previous is the electric field. This only in magnetic field equations now, ma'am.
Previous
HZ, electric field equations.
previous equations.
Electric field equations.
Previous are
This
electric
only-
field equations. Whatever we got, this is magnetic field equations. These equations is, what are these equations numbers in the textbook? What are these equation
Equation number 3.5, ma'am.
and 3.5 is given in the textbook. So we solved up to 3.4 and 3.5 equations. Now next we will see further. Next from 12. What is 12th equation? Dou z by dou x plus gamma e of x equal to j omega mu hy. From this, I am calculating which equation? I am calculating hy from 12th equation. 12th equation, write again. From this, you calculate hy. How hy is calculated? Just see here, j omega mu. You bring to this side. So it is in the numerator, other side it comes to the denominator. 1 by j omega mu times of dou z by dou x plus gamma times of e of x equal to hy. From this, I calculated hy. Hy equal to 1 by j omega mu dou z by dou x plus gamma times of e of x. Now, where I am substituting this one? Again, this hy, I am substituting in equation 8. What is equation 8, ma? From this, what is equation 8? Equation 8 is dou hz by dou y plus gamma times of hy equal to j omega epsilon ex. I am substituting in place of 8th equation. So here I substituted dou z by dou y written as it is. I wrote gamma as it is. In place of hy, what I have to substitute? 1 by this previous equation, what we got? 1 by j omega mu times of dou z by dou x plus gamma times of e of x equal to j omega e of epsilon e of x. From this, j omega mu, take individual terms. Gamma j omega mu times of dou z by dou x. Next term is gamma into gamma, gamma square by j omega mu of e of x equal to j omega epsilon e of x. From this, what I calculated? I calculated from this equation, I calculated e of x. What I am calculating from this equation? From this equation, I am calculating e of x. Just cross check how I calculated. This step is as it is. This step is as it is. This one is brought to the RHS side. Here what I have e of x. Make e of x common. Here what is the term? The term is j omega epsilon. J omega epsilon plus gamma. If you come to the RHS side, it is minus gamma square j omega mu. And next term is these two are LCM. After simplification of the LCM, final step, I got this one. What is the final equation, ma? Final equation is Ex is equals to minus kc square j omega This one I am getting. Oh. For EX, here you have dou Y, here you have dou X. For EY term, you have dou X, next term is dou Y. Same. So we are writing again 4 equations. EX, EY. Similarly, I am writing HX, XY. If I write here, we get up to rectangular waveguide equations. So totally how many equations we simplified here? First, I wrote 4 components. What are the 4 components? HX, HY here. Eight, 9, 10 is the major equations. Next major equations is what? 14, 15, 16 are the next major equations. From here, what I calculated? From this, again I calculated totals 4 equations. Value of EX, value of EY, value of EZ, value of HX, HY. Where these equations in the textbook, just cross check. EX, EY, HS, HY. EX, EY, HX, HY is equation number 3.10. Equation number 3.12.
EY 3.12.
3.1314. This is very, very, very important essay question. First unit మీరు కంపల్సరీ అందరూ చదవాలి. ఎందుకు ఇందులోకి ఒక్కటన్నా రెండన్నా essay questions వస్తాయి. How we are saying 1 or 2? Wherever you have 3 units, there 2 essay questions may be chances of covering. So here rectangular waveguide, cutoff wavelength, passive devices అందరూ చదవాలి. ఫస్ట్ యూనిట్ కంపల్సరీ చదవాలి. ఈ డెరివేషన్స్ ప్రాక్టీస్ చేయాలి. So finally, we are calculating EX, EY as well as HX, HY. By calculating these electric field components and magnetic field components of which waveguide we calculated? All these things equations is related to which one, ma? Is it circular waveguide or rectangular waveguide?
Rectangular waveguide.
We calculated all these things for rectangular
Rectangular
waveguide.
waveguide.
Previously, we saw one constant. Did you observe constant KC square? Where we got this KC square? In the
Gamma
previous derivation. KC square ekkada vachindi previous derivation lo. Vachida ekkadana?
Yes, ma'am.
First lo vachindi, first page. What is this one?
Gamma square plus
Gamma
omega
square plus omega square mu
Epsilon.
epsilon is equal to what? KC square.
square.
Now I am simplifying only this part. Gamma square plus omega square mu epsilon equal to KC square. From that, I am writing further equation. KC square equal gamma square plus omega square mu epsilon. From that, what I am writing? I am writing gamma. What is gamma?
Under root
Of KC square minus omega square mu epsilon. From there, I am writing the value of omega c. Omega c equal to 2 pi f. What is omega? 2 pi fc. Next, kc by mu epsilon. How we got this one? We have one formula. In the free space, we can also treat as mu epsilon. To omega c equal to 2 pi f. Or this is or. This is or. How we got this one? Kc square is equal to kadama. Kc is 1 minute. Erase just
From above equation only, na?
From above equation only you will get. If it is equated to 0, you will get omega as kc by under root of mu epsilon. These two are equated. These two are equated. From equating, I am calculating wavelength. What is wavelength lambda? Lambda I calculated as 2 pi omega c by under root of mu epsilon. Calculated. What we calculated? We calculated wavelength lambda c. After calculating lambda c, I am saying as transfer magnetic waves, transfer electric waves. For this, two boundary conditions we have. E of tangential. If y components are 0, y is from 0 to b. Suppose if x components are 0, y, what are the boundary conditions? The boundary conditions are x is equal to 0 to a, y equal to 0 to b. These two are tangential. ఇక్కడ వరకు ఒక ఆన్సర్ అమ్మా. I will share again 2-page view చేస్తాను. ఇక్కడ వరకు ఉంది. ఆన్సర్ మీరు రాయాలి.
Maybe it is 6 pages or 7 pages. 6 or 7 pages, ma'am. Maybe.
అరౌండ్ ఎగ్జాక్ట్. ఎక్కడ నుంచి స్టార్ట్ అయింది ఇది? రెక్టాంగులర్ వేవ్ గైడ్ అంటే ఇది రాసి క్యారెక్టరిస్టిక్స్ ఆఫ్ రెక్టాంగులర్ వేవ్ గైడ్ అని అడుగుతాడు. క్యారెక్టరిస్టిక్స్ ఆఫ్ రెక్టాంగులర్ వేవ్ గైడ్ అంటే మీరు కేసీ స్క్వేర్ ఈక్వేషన్ సింప్లిఫై చేయకుండా కానీ ఈ ఈక్వేషన్స్ వరకు రాయాలి. 14, 15, 16, 17 ఉన్నాయా? 14, 15, 16, 17 ఈక్వేషన్స్ వరకు సింప్లిఫై చేస్తే ఏమవుతుంది ఆన్సర్? క్యారెక్టరిస్టిక్స్ ఆఫ్ క్వశ్చన్ ఒకసారి చాప్టర్ వెనకాల బ్యాక్ సైడ్ పేజెస్ ఓపెన్ చేయడము.
Yes, ma'am.
క్వశ్చన్స్
3
ఏమేమి
questions are given
ఇప్పుడు
about
మనం
wave
డిస్కస్
guides.
చేసింది చూడండి.
Yes, ma'am.
వాట్ ఆర్ ద క్యారెక్టరిస్టిక్స్ ఆఫ్ రెక్టాంగులర్ వేవ్ గైడ్ ఉందా?
Yes, ma'am.
దానికి ఆన్సర్ ఇంత రాయాలి.
Another third question is also there, ma'am. Derive the field equations in the
ఫీల్డ్
rectangle.
ఈక్వేషన్ అంటే నెక్స్ట్ ఇంకా ఉంది, అది వేరే టాపిక్. మళ్ళీ
Field equations is another topic.
ఇంకా ఫీల్డ్ ఈక్వేషన్స్ చెప్పలేదు నేను. అందులో
Okay.
ఫీల్డ్ ఈక్వేషన్స్ అంటే ఇదే రాయాలి. ఒక్క నిమిషం.
3.14 ఉంది కదా మ్యామ్, దీస్ ఈక్వేషన్స్ ఆర్ నోన్ యాజ్ ఫీల్డ్ ఈక్వేషన్స్ అని ఉంది. అంటే 3.14 వరకు ఫీల్డ్ ఈక్వేషన్స్ మ్యామ్ ఇది.
అవును, 3.14 వరకు ఫీల్డ్ ఈక్వేషన్స్. అవును.
Okay, ma'am. Clear.
క్యారెక్టరిస్టిక్స్ అన్నారు అనుకోండి, మొత్తం ఫస్ట్ లో
Up
థియరీ
to-
పార్ట్ ఉంది కదా, వాట్ ఈస్ రెక్టాంగులర్ వేవ్ గైడ్ అని.
Up to boundary conditions, we have to write the characteristics, ma'am. Boundary conditions. X is equal to 0 to a, y is equal to 0.
ఒక్క నిమిషం. అక్కడ వరకు రాయాలి
Characteristics.
క్యారెక్టరిస్టిక్స్. క్యారెక్టరిస్టిక్స్ అయినా అలా ఫీల్డ్ ఈక్వేషన్స్ కవర్ అవుతాయి.
Yes, ma'am. Both are the same.
ఇంకా సర్క్యులర్ వేవ్ గైడ్స్ మనం డిస్కస్ చేయలేదు. నేను రేపు క్లాస్ లో చెప్తాను. కొంచెం మీరు ఏం చేయండి అంటే రివైజ్ చేయండి రేపటి క్లాస్ కి. అట్లీస్ట్ బుక్ ఓపెన్ చేసి చూడండి ఏమేమి టాపిక్స్ ఉన్నాయని.
Okay, ma'am.
మీకు నేను చెప్పేది ఈజీగా అర్థమవుతుంది. సో we discussed today characteristics of rectangular waveguide as well as derive the field equations in rectangular waveguide అయిపోయింది. నెక్స్ట్ క్లాస్ లో టీఎం వేవ్ చూద్దాం. టీఎం వేవ్, మళ్ళీ తర్వాత ఫీల్డ్ ఈక్వేషన్స్ ఆఫ్ టీఎం వేవ్స్, మళ్ళీ తర్వాత ఫీల్డ్ పారామీటర్స్ ఆఫ్ టీఈ వేవ్స్, సర్క్యులర్ వేవ్ గైడ్స్, ఇంకా మొత్తం అవుతుంది ఇదే టాపిక్. ఓకే, ఎక్కడ వరకు చేసామా మనం ఇప్పుడు? TE wave is completed. Field equations of what we completed? Field equations of
Rectangular waveguide.
rectangular TE, transmission of electric field we completed. In the next continuation, what we have? TM wave.
Oh, only electric field only completed.
TE mode మాత్రమే అయ్యింది ఈరోజు. నెక్స్ట్ ఉంది చూడండి టీఎం వేవ్స్.
Okay, ma'am.
నెక్స్ట్ కంటిన్యూషన్ ఏముంది చూడండి టీఎం వేవ్స్ తర్వాత. టీఎం వేవ్స్ తర్వాత ఎలక్ట్రిక్ టీఈ మోడ్. టీఈ మోడ్ సపరేట్ ఉంది. మనం ఓన్లీ క్యారెక్టరిస్టిక్స్ చూసాం ఇప్పుడు. తర్వాత టీఎం మోడ్ ఉంది, తర్వాత టీఈ మోడ్ ఉంది. నెక్స్ట్ మళ్ళీ సర్క్యులర్ వేవ్ గైడ్ వస్తుంది. మళ్ళీ సర్క్యులర్ వేవ్ గైడ్ ఫీల్డ్ స్ట్రెంత్ ఇంకా ఇందులో లేదు, నోట్స్ లో ఫీల్డ్ స్ట్రెంత్ రాయలేదు. ఫీల్డ్ స్ట్రెంత్ కూడా ఉంటుంది మళ్ళీ. టెక్స్ట్ బుక్ లో ఉంది చూడండి అమ్మా ఫీల్డ్ స్ట్రెంత్, పేజ్ నంబర్.
ఫీల్డ్ ప్యాటర్న్ టీఈ వేవ్ ఉంది మ్యామ్.
ఫీల్డ్